one, I don't remember name, uh, asking for the course to enroll or audit. I'm not sure. Okay, so okay, that's a different thing. Um, okay, I will go one by one. It's up to you from who starts. Like for me, um, very few things I would like to know from you that what do you mean by this course and what are you expecting from this course by taking it? Why do you choose this course? Um, Second one is in what extent do you see this one and what are the backgrounds do you think these are essential for you and why are you thinking of this course is a kind of like it is adding something in our skill set. A rough 3 to 4 things I would like to know from you. Like if you don't know anything or just took randomly, that's okay, fine. You might have exercised it before taking it to the benefit of yourself. Of course, everybody choose the courses the way uh, to not to waste the time, of course. Okay, let us have a conversation. Then we will start slowly.
So last semester you have teached some topics related to sir this activation and give some code also. So sir that was too much fascinating. So I want to learn more about it. That's why I choose this.
Okay, fine. And others, I would like to go Sonam Kumari.
Yes, sir.
Yeah, I, yes, tell me your point of view.
That to improve my skill
Okay,
in the field of AIML.
okay. Do you think it is a mathematics course or a computers course?
Sir, it is a combination of both, I think.
Okay, fine. Next, tell me your point of. I don't need to pick your names. You tell your point of view, whatever you feel, or like not just of this course, or like what is your interest, especially in your career next time, or whenever you choose your building your career procedure, how it is being added to it. Sri Lanka, are you there? Dhanush,
Sir,
yeah, please.
sir, like I have worked on I have worked on machine learning last time in internship, and like I like
I could not
creating
hear you properly. You may text your opinion. You may text it in the chat box so that I can read it. Okay. So those who are not having a proper conversation or machine, like you can chat it up. It doesn't matter the way you communicate. Priya,
Yes, sir.
hi, how are you?
I'm fine, sir.
Okay, how's going?
Huh?
The new courses, how is going? Everything like the courses I think you started with.
I think it's going pretty smooth right now.
Okay, good. So tell me your point of view on this neural network.
Uh, I think that it would be more beneficial than studying at a Python,
Okay.
it is a
Uh, who else is there? Ganapati? Pragya? I forget one more name.
Sir, actually, I want to learn more. I don't know a lot still, but want to continue in this.
Okay. Right. Okay. I will not go something today to discuss directly the neural network. What is a neural network? All these things will come in the days later, maybe next week, not even this week. Because I think I remember sometimes I used to write up some kind of neural networks with the mathematical equations. Um like so as you are from mathematics background and further away, rather than knowing how artificial intelligence is taking place into the life of various tasks doing by itself, which are all fascinating. Everybody knows that, like even those who are not technical, those who are not in the technical field, not even the tech savvy or in any other field, they would just says whatever field you choose, art, business, no matter, even the people doesn't have any idea of what technology, how this technology is doing, the they talk, everybody, because that is how this is an importance of it. Earlier seems like computer programming is traditional computing, traditional software development or computing is only limited to few people, those who are technically sound. And but this is something different because it is seeping into every domain. So one has to know how to use it at least. Okay. So, uh, even I see many, even that strong tech experts in the AI, in machine learning, or whatever, the prompt people, the way they handle the data, the way they produce their tasks done by artificial intelligence tools, many doesn't know what actually how it is doing. I don't say all, many. So the gap, even you know it, like the many applications you use it, the many applications you see, you already experienced by trying them out, like identifying the objects, or videos generation, or text generation, or image generation, or detecting objects. These are all very few fundamentals, and there are many applications or tools out. You may best know better than me what are all things are playing around. uh, Now my fundamental question of all these things is how these are all possible, what actual core thing is doing it. It may be slightly different from one application or one tool to other, or whatever artificial intelligence aspect it is doing. So there must be some core philosophical idea or technical area or kind of a physics is doing behind it. A natural way of process is doing it behind the lines. So that need to be explored. So that is not the program. The programming is a kind of a kind of writing up the concept on top of it to such that it is working it. So now my interaction with you, maybe I would ask you, or you may come forward and let me know that why this artificial intelligence is working. Why? How come this is? How this is functioning? What is the core idea? In any aspect, any whatever ground knowledge do you have so far, you can use it and tell me why it is working. You see, the lot of things are happening outside. So why? What is what it is doing? Why it is doing? Now everybody using it and saying and probably like this is happening, that is happening in the artificial intelligence world. These are all connected. You don't think of too much about the wording like machine learning, artificial intelligence, or deep learning, or data science, or statistical learning. All these are siblings of one another. So uh, what is neural network in it? So these are all pieces of concepts are working together, or some of them working independently. So anyhow, all these things are collectively called as a kind of like a new technology. That is what we are using it right now. Um, so so now my question, you understand uh, why this hype, or why this is so far we come here. You might have, you are the transition people, you have seen maybe 5 years back where you are in our school times, or you are started listening, maybe artificial intelligence is coming. Before that you might not aware of it, or for me it is a kind of different thing I have experienced for the programming, real programming world, and a transition to the artificial intelligence world. It is a clear picture I have, but you may not have that because you are just started into the tech world, and that is the point where it is emerged. Of course, it is emerged long before, but it is coming into the line of directly into your classrooms, directly into your hands, so that you can adapt. And you don't need to search for where it is and how the texts are developed. That is so much fine. Like, okay, let us go ahead from you. Uh, uh, what do you think in general perspective? You just discuss. You don't think too much on the subject perspective. You just a debate, a kind of thing. You can counter argue with among yourselves. That doesn't matter to me. I just wanted to listen the conversation, a healthy conversation among yourself or with me. I will just stay here for a couple of minutes. So yeah, start with anyone, like why this tech is working.
Sir, in my opinion,
Yeah, yeah, anyone. Okay, the way machine itself machine correcting itself what we are doing wrong. So yeah, that's understandable by the things. That is what you are saying. It is the learning procedure. Am I correct? If the learning definition. Machine is learning itself. My question is not about it like why it is learning, why it is possible, how it is possible, instead of why, how you can say.
Like, sir, in human life, from childhood, sir, we are learning from what we are doing and our surrounding. So, human think that ki we can build some tools like that. Ki in the initially, if we give some data, based on that response, that tool can learn from how the users use them to like how we use our AI, how we talk to our AI tool. Based on our conversation, they enhance our response skill, we can say.
Yes, yes, yeah, yeah, yeah. Some extent here extended what Ganapati said. Okay. Anybody others? I just wanted to listen so that we can discuss further. Once, just join voluntarily yourself to give your comments. It is a kind of like, you engage yourself so that you will be knowing or practicing yourself to come out of your thoughts so that it will be, you will be expressive enough when you enter into the world of um, whatever job or whatever role you pick up in the future. So that you have to practice while you are in the classroom. We all may not be correct all the time. You don't need to be answer like a question and answer thing. What is right and what is wrong? There is nothing called right and wrong. Only the things we discuss as a progressive things to become progressive ideology. Yeah. So why this is learning is possible? Mm, okay. Yeah, that is nothing like uh, something like I think we decipher our brain. Is it really brain? The way we thought process, the way we learn, it is all about uh, in the nutshell or in the ground level. It is a combination of chemicals, the chemical and the electro. I am not sure I'm like the special the transitions what happens during the neurons they evolve inside our brain, that cells communication system is that is somewhat extent, that is I can say like it is an inspiration. We can say that's a kind of inspiration we developed this one, but um, that that biological communication, the biological wiring, what we have naturally, I don't think that is possible in maybe in the at least for time being uh, to bring that same into our machine. That is a kind of that is a inspiration to develop such um, neural setting. Maybe the word what we are using, that is a neuron inspired from the brain cells, the brain neurons, so called. Um, does it actually? Does it really? Does it? Is it? Can we relate somehow? Or uh, I'm not sure. Like one of the fact. Once it bring it down to No, I can pose something like this: is the biologist sees how neuron is functioning, and then if they try to decipher or decode how it is functioning into a language of algorithm or procedure and bring it down to the line of model or a computing setting. Hmm, I'm not sure. Like that is way far from, at least in the current world. So by it is for my strong feel, it is a independent development irrespective of what brain is doing, but the similarities to define the coincidence of what neurons are doing in our brain, the cell communication, it is somehow it is matches the way it is learning in the machine. So that is how the bridge between these two, but there is no direct correlation, or there is no direct deciphering. I don't, if somebody saying like it is a decipher or it is a decode from the our natural brain system, I don't agree. So because that is not at possible at the moment, it may take maybe further years or hundreds of years. Nobody cannot judge that, but it is an independent development, I could say. But there are similarities, but the way it pumps in the data, the way it learns the neurons, there are quite similarities, not 100% similarities, but few similarities, I could say. Uh, the chemicals, how the chemicals get processed when you listen something, when I am saying something, your brain is processing the communication, the memorization, the data which you have already, and the data which you are currently receiving. These are all in the level of chemistry, biological chemistry, but not in the case of like you cannot bring down that communication system into the mathematics as of now. But this is a purely, unless we have some algorithm way, or unless we have some equations into the math setting, that is not possible for our current tech world. Okay, the neural network and the brain neurons, these many articles or textbooks even, they quote these things that this is the neuron, this is that one, that, but don't think of that it is a direct decoding. It is independent development, but we can to, in the sense of to uh, bring you the world into the kind of like we are naturally developing, but it is not. The way the biology and the way these neurons work are completely different. So we cannot bring that our that training procedure. I think if you remember correctly, I mentioned some kind of like the sigmoid or activation function or the linear algebra do we use. There is nothing called such things are in our brain. That is not a decode of our brain. There is no such systems or numerical systems in our neurons. This is completely pure perspective of our own development of text by brain. So yeah, just to go ahead. Like I will keep talk on um, further. You just tell me why this.
Can
Yeah,
you,
yeah, Dhanush.
sir, maybe the
I think I can't hear you, or it maybe. Um, Well, yeah, I think okay. I think you better write the text so that I can read. You have already written a text, I guess. Yeah. Okay, this is for my earlier one. Yeah. Okay, fine. I understand our texting. Okay, that's maybe uh, we will go ahead in this direction. The mathematics behind the neural networks. Yeah.
Sir, now can
Sir, can you hear me now?
Yes. Yes. Go ahead. I can hear you, Ganesh.
Sir, maybe these models are working because we have developed them so that they can understand the pattern given a data. So,
Yeah. We have developed. That is what we are seeing. That is my um, why these models are working. My question is like, why these are possible? Isn't it fascinating? Why this is like something? Sometime, some point of time, the curiosity kicks in and uh, asks yourself like how it is possible, why this machine can learn, uh, what is the core reason, the go to that point of the touching point. If we could able to, yes, this is the property we have. See, we have the, electricity, the you may be fascinated at very first time you are thinking on it in our school times, how electricity is making a lot of easy things are easy in our human life, how how the rapid change in the human, um, what we call like the lifestyle, whatever, the complete the transition from the dark age before electricity and now if you think on that one, how it is possible. Yeah, you know it, ground reasons, you already studied them. What is an electron means, what is a property of a electron in a material. The so much science you have already studied in our school times, so that you know what is electricity very clearly at the ground level. uh, the how the electricity is passing and how it is generated, how it is doing the converting energy from uh, one form to other form, like any mechanical to sound or whatever, like all possible transition machines are doing by electricity. That's, you know it very well. Then and if you, even if you don't know some of them, you read them, like you would understand very clearly, ah, this is the nice thing, this is the property which is causing to do this task. So you can see at the level of molecules what's happening, and how the electrons are vibrating, how the electrons are balancing the potential difference. All these things, you know it, if I am correct, like if you at this point of time. So uh, that is not much fascinating to you because you know it everything. So if all these definitions or all these conceptual ideas, and what is a molecule structure, like the electron levels, like sp1 hybridization, sp2 hybridization, there are a lot of chemical levels where the electron states are being defined, where what is a free radical or free electron, which is always trying to pass the electron from um, one molecule to other molecule. So that is, if there is no free electron, you can't use that material to pass the electricity. I think you know all this. What I'm just roughly sketching what's happening. So like you cannot use some of the materials for transit, like pass the electricity, because you may not find a free electron to transfer the electricity. That's, you know it. That is what the some of the materials like copper uh, always have one free electron, and which is slight less energy state, if I am remembering correctly. So it does the job very fast, so that we say uh, that is a best conductor as of cheap and best. I don't say it is a best. Even still there are resistance. This, you know it in a ground way. Why the how it, you are not just using the applications of these electronic devices, electrical items, and some extent you know them. Why, how, in the that level. Now the same question comes to this one. Why I'm analyzing, bringing this analogy. Why, how this is possible? How a machine is doing it? That ground truth of the learning, that we have developed models, of course, that is true. We have, so that machine is learning on its own. That is what we are looking at them. So how can we develop a model such that the machine is learning? The model, whatever you say, then you name it, there are hundreds and thousands of models. Every day you see there is a new model coming out. Even that may not be popular, but of course, somewhere in the world, always there is a model is coming out every day, every hour, I could say. So, uh, so if the ground truth is the key to know why this is, how this is possible, that is the question to address. So you understand what exactly I am directing. Do you?
Yes, sir.
Yeah. So this course neural networks is I think the syllabus, you can see in our syllabus copy. Maybe I will share uh, uh, that actually it is a theory course by description of the course itself. It is a kind of like describing neural networks, what is a neural network, and how a neural network works, and how the data being passed and data being uh, taken into the neural network, and how it is learns all these things. But the way I ask the questions as of now, till now in this discussion, this doesn't answer robustly with our same syllabus. So I will little extend all of those terminologies into my own way of the neural networks. The same, but it is no more a theory course. Okay, this is completely a kind of a knowing the ground truths. Okay, so this the lot of principles you are learning, the definitions, properties, and sometimes a little outside of tech world. Direct, you don't see. My point is like you may not see any algorithm or any kind of Python or any kind of a program um, until it realizes the concept into algorithm level, the model level, because you are all answering my questions because the world is hidden the things like the models are hidden, hiding the actual the core things. So you are working almost all the time, whatever projects you choose, directly, yeah, this is the project and this is the model, you use it, this is the data sets, or this is the data being given to you, or collect the data and work on it, these are the rules framed by this data, and so on, so principles, so that the model is taking over the actual task to do it. But this is a very beginning world. There is no problem to working with models. And later stage, some point of time may come in your future, or maybe now, or very near. You or the world, or maybe the place where you are working, or the maybe by yourself, you may encounter a problem in the industry, or the real life problem that doesn't have any model yet. So you don't know it. Whatever model you try it, it is failing because of the nature of the physics sitting inside the problem uh, is not there to model it. The data is to train it or to learn it. There is no such model fitting for the data, or the complexity of the problem is so high such that. So then you may have to come up with your own idea to build a model on your own from the scratch. From the scratch. That means that so from the scratch means what you have to do, you have to understand the physics of the problem, the nature of the problem, from that physics and from that ground truths, from that ideology, you have to think parallelly how do you build a model, or how do you kind of write a structural design, then prove it yourself. This will work it out. Then once you prove and very robust rules, you make robust rules on the data from the point of the problem. Then once you convince yourself these are all working good theoretically, and then you code them up into a model level. That is how anybody develops a model. Suppose some let's say some chemical interaction in a drug you wanted to study, some very complex viruses are evolving from bacteria, or in the colony of bacteria, or in the animal kingdom, and the way they are propagating, the way they are spreading, the way they are mutating themselves, which is so complex. But you suppose if you are a biologist and you know the complete the biological spectrum, biological understanding, but now you wanted to see future perspective, or you wanted to update the information what's happening in the world of that microbiological level into a model. Suppose you see that, like, if you are working on if you are a tech person as well as you are a biologist, then the question comes now, the to build a model, then you have to think on the physics of the problem. I mean here physics in the sense like what's happening in the material world, whether it is a biology or it is any kind of anything which is happening in our uh, what we can, or what we have already coded from the nature. Like it can be anything, chemistry, biology, physics, no matter, we named all of them, doesn't matter. So so now what to make our own things, you should know fundamental things, fundamental ground truths, ground the way these are all working, why they are working. So to design our own model, or to design our to solve a problem on our own. So yeah, uh, So this is oh, uh, what is the course is going to discuss. We don't discuss all these applications point of view or design a model or no, I rarely touch up the models because the models is not the perspective of this course. uh, there are thousands of models are coming out. We cannot go behind them to exhaust or to know everything. It's not possible at all. It is even either of anyone. It is not possible to know every model coming out. Like, but the model which you are working, like, is it only solving ever domain problems that you have to take care. So knowing artificial intelligence, knowing machine learning doesn't mean that you are doing all domain problems. You are not doing all the domain problems. So this is a kind of a tool like a mathematics. Mathematics is, if you know masters in mathematics, doesn't mean that you can apply mathematics in all the fields. That is, you need a what do you call domain knowledge. The same math may be used in their domain, but the experts in the domain knowledge, they use the mathematics for their own convenience. How the quadratic equation or the how probability working for them is different. The way it is, you look at it different for themselves. That is, for them it is a different thing because the way they apply in their own field, it can be anything. It doesn't matter. There is no borders of the fields or domain knowledges. So you should understand domain knowledge is the great thing to understand or to develop a model always. But what we don't touch any of the domains. Just like mathematics, learning a mathematics is a purely tools or formulas or understanding how they are working. The same way we learn this neural networks, irrespective of how it is applied in a particular domain. Okay.
Sir,
Yeah. Yeah, please.
sir, maybe AI is working because, sir, AI, like, whenever we build a model, it is essential mathematical model, right? Which
Yeah,
is
yeah,
approximating a function, recognizing the pattern.
yeah.
So maybe AI is a proof for showing that mathematics is built into the nature of things which can recognize patterns.
Yeah, you are coming to the point where the models, like the solutions or the solutions of the problems in the world um, are in the nature of the language what we build, so-called mathematics. So from that we build the model. That is what you said. But now, even in the mathematics, unless there are some uh, some considerations, some what we call conditions, if this happens, if this happens, if this, then only it works. This works. What are those ifs? Suppose if there is a future problem comes in front of us, and the if is causing the problem, the condition whatever we pose today, that is creating a problem to solve a new problem, then we are at end of the point where we cannot solve. The if and buts are the so critical in this. Like, um, how do we come across all those? That's we see all these conditions, how they are playing. We will begin, maybe as I said beginning, we'll start with very rough mathematics. Maybe you may know most of mathematics what I describe. and but it may be a recap, and I will explain in my own terms the way you may not currently connect with the neural networks at the very first glance while looking at them. Why you may feel like, why am I discussing all these things? But you will later know it. These are all uh, being utilized inside our machine, our neural networks. Okay, I'll share my screen. Okay, before that, I would like to know the courses currently which are running, so that I will have an idea of what is there any potential overlaps or potential mathematics being maybe I'm using this. Uh, Let me know any other courses which you are learning. I think you have already known the optimization. I guess you have finished it in the last semester or before. Optimization very well, I guess. Yeah. Yeah. Let me know what is
Yes, sir.
called. Yeah. Please. What's going in this current semester?
Sir, am I audible?
Yeah. Yeah. Please.
So in this semester we are studying fluid dynamics, stochastic calculus,
Okay.
and neural networks,
Okay.
and AI, artificial intelligence, theory of computation, and
Okay.
functional analysis.
Very good. Right. Okay. Okay. For me, mm, functional analysis, some extent can be used in this functional analysis, but I don't go all these Banach spaces and all, but different spaces, I don't think like directly I'm using the functional analysis, but some of the norms, norm linear analysis and LA will be there, that I may use few norms. Mm, and the spaces, some spaces I may use it, that may not be directly sitting inside our functional analysis, but these are all parallel spaces which are in the functional spaces. Okay, and mm, uh, optimization is major thing to me. That's you have already done. That's I don't have any problem with that. Uh, have you ever had a
Sir,
course? Yeah, yeah, please.
sir, you will use non-linear optimization or linear optimization? Last, both.
We use non-linear optimization.
Okay, sir.
Okay,
Okay,
it
sir. Go
doesn't
ahead.
matter
What?
whatever optimization, you know it, what is optimization that is sufficient of, irrespective of what it solves. Okay. Have you ever come across measure theory course, or it is in the future semesters, or measure theory? Is there any course called measure theory in your curriculum?
Sir,
Mm,
till now, sir, we did not study it.
okay.
Mm,
Okay, no problem. Okay, I will slowly touch it because that's what we use in the major part, but irrespective of
Sir,
whether it's,
maybe we have
yeah.
slightly touched it in stochastic calculus, sir.
Okay, okay. Measure theory. Okay, no problem. No problem. I will define everything, but you may have to extend yourself, whatever I described in the class, define definitions. I may not go as because I cannot cover the requirements, everything within this. So you may go ahead and further read on yourself if you are struggling with those ideas, concepts, so that it can help. But at least you should know. uh, I will bring to the point where that can be understandable and usable. That is okay. Right. I will start with some few definitions of the mathematics only today, or maybe this week. We'll not touching into the what is neural network, the definition of neural network, or maybe the related things may come in the next week's next further lectures. But wait for that time. But today I will just give the few definitions of mathematics, or maybe I don't think of like these are definitions or something. We'll just play them. We'll just discuss rather than just I am writing and reading from your end. Uh, is my screen visible?
Yes, sir.
Okay, good. Okay. Mm, I think you know the real analysis. I think I discussed the real analysis. I don't. The real analysis teaches the fundamentals of real numbers and all. Like now, I go with a few uh, ideas extracted from the real analysis, which we are essential things. Okay. Um, Let me first write it up some set notation. This is RD. So RD is a kind of sets like X1, X2, and so on. XD such that each Xi belongs to real numbers. It's a D-dimensional real space. This you know it very well. Usually you may see Rn, but 10 dimensional, but I write D dimensional, D for dimension. Now I have two simple questions for you on this RD. The question number one, you think on it like no worry. If a set Y is a subset of RD, I'm not describing what is this Y, just a subset of RD. If I say is big, I said it is a big, and I don't know how do I define the bigness. But I said is big. Now my question is RD difference Y, the complement small. I think you understand the question.
Sir, we cannot say because we don't know how big our RD, and
Yeah,
if
the Y is if I said a subset of RD is a big.
RD is
Mm. RD is big, of course. RD is infinite set, and okay. Oh no, the fundamental question comes. You may ask me, what is big? No, it is this. This is a bigness. How do you define a bigness or smallness? That comes the point where you relate two sets. If I say this is a big, and in which way you are saying it is a big, that comes in. Okay. So if I point something like the bigness, uh, uh, mm, so if I say my y is uh, that is subset RD is unbounded. It is the way I define my bigness. If I say bigness That means that if you see, if I find any unbounded set, that I can talk it as it is a big. Maybe some other non-unbounded sets may be a big, but I don't talk on them right now for a moment. If I say that my I see unbounded sets are big sets. Maybe another point I would say, like for smallness, I could say another one more. If Y is subset of RD, this one I call it as a bigness. It's not the definition, the one way of saying Y is subset of RD is finite set, any finite set. I could say this is a small set. The intuition says unbounded sets may be bigger sets because I don't know on the complete world, because still it is unbounded. It is still goes like uh, it keeps on running like Q. If I take, yeah, of course, it is unbounded. There is what is unbounded. Bound, you might have seen in our real analysis. You have seen least upper bound, LUB, and greatest lower bound, GLB. That means if you have something, you have a point where then all numbers will have um, LUB, least upper bound, and greatest lower bound. So, so that means that the set is strictly sitting between two bounds. Yeah. So this is a lower bound, I could say. This is upper bound, you can say. The greatest lower bound can be sitting somewhere close to this one. The least upper bound comes here. So then we say that if any set having LUB and GLB, then we say it is bounded. Otherwise, it is unbounded. If you cannot able to pick up these spikes, the least upper bound and greatest lower bound, then we don't call it as bounded. So now you worry too much maybe at this point why this is, why need this unboundedness and finiteness. Of course, these are all directly connected to our concept to understand. So maybe I could explain in a rough sketch or rough terminology. Okay, why are we learning this? Suppose you have a model. Assume that, irrespective of how it is built, it is working for a data, and you are keep supplying the data, which is not from a which is not having any control. Not having any control means there is no way you can correlate one instance with other instance. It is keep up piling it up irrespective of new patterns are predicted. So there is full of chaos or full of uh, uh, there is no exhaustion in the data. It is keep generating um, without any bounds. There are no limits. No limits for the data. It is in RD, of course. The data. What you mean by it is from RD only, right? Some subset in the RD. You see any data, some way, some whatever data may be, either image or video or whatever, the text, no matter whatever it is, some way you have to bring it that into the some subset of this one only. Do you agree? Do you see that? The data you play with.
Yes, sir.
Yeah. So we need to understand the properties of the subsets very closely.
Sir,
Yeah.
I have one doubt, sir. How
Yeah.
we can our if we using ChatGPT or something AI tool, we
Yeah.
give some prompt in text format.
Hmm.
How it converts in RD form, like
Okay. That's to make touch later, not at this point of time. That is that is model descriptions. This is something called tokenization techniques. Okay, that we will discuss at the time when
okay, sir.
we touch some models. Because every model describes the data in their own different way based on the how model is built. That is, in this case, the model is, the model name called LLMs. Okay,
Yes, sir. Large language model, yes, sir.
yeah. So you should understand how the model is designed by based on that model definition. You will clearly see that RD. Yeah. So it's not
Okay,
straight that like the every model of the same way. Some black box, it is taking input and it is giving output.
okay, sir.
Yeah. So let us understand abstractions of doing these things. Yeah, the question is the number one. If Y is subset of RD is big, my question is, can I say is RD difference Y small? The complement, can I say it is a small? For the understanding of the big and small, I gave two notions, two ways of saying. I don't say it is direct, but one is if I could see a set is unbounded, then I can say it is a big. If I compare these two, if I gave you a unbounded set and a finite set, I don't say what are those contents, but yeah, if I ask you to relate, then one can say, yeah, unbounded sets are really big. Yeah, finite sets, of course, they are small because there are large sets are sitting inside RD, such as unbounded, infinite things. Yeah.
So, sir, based on these two
Mm,
definition, like big and
mm,
small,
mm.
RD is also unbounded, sir.
Yeah, RD is unbounded. Very good. Yeah.
And Y is subset of RD is big, it is also unbounded. If we take complement of two, it will also come a unbounded set. So then it is not correct based on
Yeah.
these two definitions.
Okay. Then okay, I
Sir,
will
it
write. Okay.
can be bounded and unbounded both, sir.
Yeah. Okay. Yeah, it can be bounded and unbounded. So we cannot say that. Yeah, of course, like complement of an unbounded set can also be unbounded. That is true and can be both bounded. So if it is, you cannot able to concretely come to a point where bounded sets, and if it is failing by one instance, that means the statement is failed. You cannot say, right? So that is negative answer. Like no.
Yes, sir.
So, okay, I don't go for much explanations with that. You can see another question like if on the same contrary of the same, if y1, y2 are subsets or maybe a countable subsets. I don't say it is yn because I am not stopping. It is keep countable sets, countably many, and so on. Uh, are subsets of RD are small. I say all these are small sets are countable sets. My question is union of n equal to or k equal to 1 to infinity, the yk small.
Sir, if y1, y2 they are small, that means they are finite set based on a small definition, sir. So
Okay.
union of all finite set, it is
Hmm.
also finite.
Okay. Is it?
Then
Do you agree? Everybody agree? Like, okay, I am writing your
Sir,
point.
no, sir.
Yeah.
It can be smaller, it can be big, based on how many sets we are taking. If you take
Okay.
finite set, it will be small. If you take infinite set, it will be big.
Okay. But okay, writing up like it's a nice thing. Uh, you are saying countable union, right? We are doing all the countable union, countable collection of countable. It may be infinite sets, but they are countable. Countable union of finite sets. Okay, dash is the collection union of. Is it finite or infinite? Hmm. Think on everyone like come to why that is like countable union of finite sets is again finite. Oh, yeah. Countable union of finite sets. No, no, it may be countable. I'm not asking about countable. Countable union of finite sets is um finite or infinite. That is what my point. Bounded or unbounded. We have to say whether in the context of small or big, right? Our target is to say um, finite sets is maybe options. I could say uh, finite sets. Finite. Finite means always countable. Be infinite. C unbounded. Maybe multiple answers may correct. D bounded. What are all possible chances? Like that, of course, depends on y1, y2, and so on. Uh, if I, if my question is on the smallness, if there is any collection which is comes as unbounded, according to me, it is failing. If it is comes, if any collection, if you give and union of all these things gives unbounded set, then I cannot say it is a small according to our smallness and bigness.
The union of finite set is always finite.
Found it is all union of finite sets. It is not the finite sets. It is not the finite number of sets. Of course, these sets are finite. That means y1 has some number of elements, y2 has some number of elements, y3 has some number of elements, finite number of elements. But the sets are itself not finite. The
Okay, sir.
sets are infinite sets, countable infinite,
Countable. Then, sir,
countable. Yeah.
then maybe if sets are infinite, then their union may be an infinite set.
Yeah, bounded
Bounded
and
and infinite.
if okay, bounded and infinite. Okay, if it is bounded and infinite, then I cannot counter it with our bigness. Our bigness, I say it is unbounded. If we cannot
And we
bring
cannot
this,
say about our is
hmm.
we cannot say about our small also because small it is finite. If it is finite, then it is small.
Oh, that is one way of saying, but yeah, yeah, that is also true. Like either we can't say small, either we can't say big, unless we find a right candidate to decide, clearly say whether yes or no. Yeah. What about this? Huh. Oh, okay. Countable union is also bounded. Hmm. I don't agree with that. Why? Let's say my collection is like this. Okay, let me choose another color for explanation. Let's say y1 equal to my only set is 1. y2 is my only set is 2, and so on. And yn is only set is n, and so on. This is not exhausting. So now union of k equal to 1 to infinity yk is natural numbers. Is it? So,
Yes, sir. Yes, sir.
so natural numbers are unbounded.
Yes, sir.
So the answer is smallness is not working. It is can be big. So I can say it is also a no. Okay. So The way we describe the sets are big or small. Um, there, so where on like why am I coming to this discussion? To understand much better subsets like the smallness, unboundedness, boundedness, like the way we look at the sensing, we need a kind of a metric or measure. These are all kind of like whatever so far I have described. There is no formula to describe what is the small, what is the big. In a vague sense, I have bring out some kind of unboundedness, finiteness in these two contexts we discuss, but there are a lot of other contexts. We cannot say whether big or small unless we come up with a concrete definition or concrete way of saying a measurement to say a unit or a measure to say it is a big or it is a small, it is a kind of this measure. So I need a function.
Sir, what
Yeah,
is the problem currently? Like, what is the problem by choosing small and big as finite and unbounded?
what is that like small is finite and yeah, this is because everything like okay, if you come up this one, there are contradictions come up with like uh, uh, so where should I keep an infinite set, infinite bounded? So suppose if I choose 0 comma 1, this is not a finite set. This is not a bounded set. This is not an unbounded set. Okay.
Yes, sir. Yes, sir. Good.
Yeah, this I cannot keep it in either of I can say. So I just described a kind of like a few things to say. Finite set, I just said it is a finite, so that some sense we feel like okay, finite sets are tiny things. Of course, we can look at all of them by listing. So that is the smallness, but you cannot say like 0 comma 1. It looks like okay, this is also small, but at the same time, but this is infinite. They are not finite. I don't know unless I define some kind of measure or metric to say whether it is the number I have to associate. So if I bring some functionality which takes all the subsets, like I could say power set of RD. If I define some function, like a measure function, like I don't know what to use, some measure function mu, which mapping to real numbers. So every subset is associated to a real number. Based on that number, I could say whether it is a bigger or smaller. That's what I would like to focus on this collection, this function I'm targeting. Okay, this is so fundamental to understand the nature of subsets inside the RD, where we actually doing in artificial intelligence, usually this as a data sets. Okay, so data sets by nature they are finite because the data is limited. The computer generates or computer understands in the language of finiteness only. There is nothing called infinite in the computers. That is just our convention to stop for certain limit. But now, in theory, it should work mathematics for in general abstract subsets. Then only we can apply it to the computer by truncating it to a certain number. That is what we say. So if it is not possible in the theoretical sense, and we cannot bring it down to the computer language. Okay, now let us go ahead to understand a few things. There are a lot of other things, but before I will write up much concrete way this one little later, not just now. Okay. Um, I think I have defined in my real analysis lecture, I might have defined something called D box. Again, I am defining this one, D box, D dimensional box. it is so we use it several times in our further down the line. Um, what I say about the box is, if I say if you have a subset A is subset of RD, if I say that is a D D-dimensional box, if the A is uh, A is cross product of intervals, bounded intervals. That is the product. This pi is indicating the cross product. J equal to 1 to D. There are D dimensions. The ij, where these ij's are bounded intervals. That means, like, if I would like to give one box, what is the one box? One box is simply an interval, something, this one, maybe another one, kind of this one, bounded intervals. This is a one box. This is also another one box. Okay, what is a two box? Two box is something you're saying. Circle, I don't know. Circle, how it can be a box? Like, if I have something, this one, if I have two intervals, I1, this is a I1, and another interval, something say um, this one. What I written here, this is, you have two boxes, D is 2, that means A equal to pi, J equal to 2 here, with J is varying I1 and I2. So this is I2. This means that I1 cross I2. That product means. That means that, like, it is a forming a rectangle here. Kind of a rectangle. This is I1 cross I2. This is a two box. So you have intervals of I1, I2, and it is forming a two box. This is a two box. This is one box is for this one. So that means, like, what you are doing, the product of j equal to 1 to 2 ij, that means I1 cross I2. That means, like, if we have some numbers, like here it is, let's say 2 to 3, here it is, let's say 1 to 4. That means, like, 2 comma 3 interval cross 1 comma 4. Understand? If you wanted to explicitly write it up with the pairwise a comma b, such that a belongs to 2 comma 3, b belongs to 1 comma 4. It is a D box. It is a two box. It is a rectangle, right? Yeah. So three box, you can imagine there is you three box is, what is the typical shape of it? Can you name this shape? Cuboid. Yeah, it is a cuboid. You have a three-dimensional setting, x, y, G. Then you take some intervals like this, or maybe why this one? Z is somewhere else here. Then it forms outside. It is forms in the space, not on this one. Some kind of like outside of the sphere, like it will be kind of a x dimension is this one. Maybe this y is only a little bit in this, and z is height, that will be a little bit this one. So it combines all these things, comes as like this. It is sitting in the space. Is a three box cuboid. So what we are talking is a D box. D box is same thing for any D. We can visualize up to 1, 2, 3, but 4, 5 higher dimensional boxes, hyperboxes. Yeah. And now another definition of something called um, volume of a D box. Volume of D box. So I have some notion, or I think the same notation I use it in our real analysis. Volume of D box is a D box. Volume of A is, now again the same symbol I'm using it for my convenience. J equal to 1 to D is now the product of the interval lengths. So this is a volume definition. You can measure it. The measurement of the volume, let's say if it is 2 and 5, the volume is volume of A is it is 5 minus 2, the interval length. That is what cardinality, whatever, I don't call it as a cardinality, it's a length of the interval. It is 3. If it is 0 and 2, for this volume is just 2. For this one, what is the volume?
3, sir.
Yeah, this is 3 minus 2 times 4 minus 1, that is just 3. So you can measure it for any D box with this volume. Okay. So what I can define is some important definition I would like to go ahead with from this. It's kind of, we use it many times. D-dimensional D-dimensional Jordan outer content. D-dimensional Jordan outer content. Okay, don't think too much on the name, but it is quite easy. Okay, this D-dimensional Jordan outer content is actually, I will write up first that set description, then I will go for an explanation to make you understand, or maybe I will ask you like yourself. It's self-explanatory if I write the description. If I have a bounded set, okay, content uh, if y is subset of Rd, whatever we started with this one, y is subset of Rd, is a bounded bounded set. Y is a bounded set. I define Jordan outer content is some notation that is called mu star. J defines for the Jordan uh, D. There are two famous scientists, like one is Jordan and Lebesgue, and we'll see Lebesgue a little later. Um, mu star JD of Y is, I'm writing a set description. Let try to understand yourself so that you are working how this set description is visual can be visualized. So infimum of infimum, right? I don't need to mention infimum.
Yes, sir.
Infimum supremum, yeah. Okay. Infimum of summation of n equal to 1 to finite k volume of a D box, volume of a D box of each D box until KD boxes, sum of all the volume of KD boxes such that the K is from natural numbers and these ANs are the D boxes, what just we have defined above. These ANs are D boxes with Y is just, it is so important, Y is subset of union of all these D boxes. N equal to 1 to K AN. Just I am closing the set. You know the D box. Now I gave a one subset Y from RD. I don't say whether it is a D box or not. I don't know. Because if any set Y, if I gave you RD, it need not all the time it is a D box. D box is a product of kind of like intervals. That's what we have seen, like it should form some kind of any kind of bounded intervals, but we cannot describe every subset in RD as a D box. But if given bounded set and also something unbounded sets, I'm not talking right now, given bounded set, okay, given bounded set, if that like we have volume here for the for D boxes, we have a volume definition. I am trying to bring some kind of number for this Y bounded set in terms of these D boxes. You understand? Because if we give some kind of box like this, some kind of this one, some kind of this one, I have some measure to do it. I have some number to explain. Okay, this is some kind of area, some kind of volume, some kind of thing. It is there. But if I gave something which is not a D box, but of course it is a bounded set, but it is nowhere, I cannot give some number as easy as a D box I gave, but I'm trying to bring some kind of notion where I can express, I can assign a number to it in terms of D boxes such that it is covering all the, it is covering the KD boxes where this Y is lying inside. Now take your own time, 5 to 10 minutes, it doesn't matter. I try to understand what's happening in this definition, in this set. Picture yourself. Anyway, at the end I will explain, but it is always decode or decipher yourself so that you are pushing your brain to the limit that you can able to understand the language of mathematics in your own way. That's always great. You feel yourself confidence. Yeah. 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 Tell me, Ganesh. Well, sorry, X is subset of Y. Okay. No, we cannot say that, right? X is subset of Y. X, We cannot say that X is subset of Y. No. Okay, do you come up with understanding of this one? Any rough understanding at least? What it is actually telling? Some sense. Yeah, smallest volume of D boxes, some of the volumes of D boxes covered uh,
Covering Y, sir.
yeah, covering Y, exactly. So let's say if I choose some okay, let me say some kind of uh, I give my this, let's say it is a Y. Okay, let me write it up in uh, let's say this is our Y. So now what you are doing, you are trying to cover up some kind of um, with the D boxes. Suppose I can say I can take up this one D box is okay. I can take up one D box like this, and I can say another D box like this. Okay, let's say two D boxes. I'm confined to two D boxes. That means my here k equal to 2. Okay, that means that like I have a1 and a2 2D boxes. Let's say this is a1 and this is a2. And now my y, the red color, the pink color one, y, this is the y. The y is a subset of this A1 union A2, right? This is true. Now, if I wanted to write up the volume in terms of summation of volume of A1 AI for I equal to 1 to 2. So I will get two volumes and I can sum them. One is the volume of this one. Uh, let's say the volume of this one is small v1. Let's say volume of this one is small v2. Then my answer is v1 plus v2. This is one element in the set in this collection. Now what I am asking, infimum. If you look at here, there is an infimum. Infimum means the smallest of all these possible volumes of construction of this one. That means you have to look for all possible finite D boxes which satisfying this criteria such that it is completely sitting inside, so that I can bring that smallest of smallest A1 collection. It is not just the A1 and A2. It is can be any finite number. It can be 100, it can be 1,000, it can be 1 million. It doesn't matter. Right? So I have to bring all of such. So now if I write up some kind of like if I take some this one, and this one is a 1D box, this one is another D box, this one is, I'm tightening up these D boxes. I'm tightening all these D boxes so that what is happening, so you cover up these D boxes so that you will get much finer, much finer number, where you will get this smallest number which is given by the sum of the D boxes. So then I can use that number as measure of this y. This y I can measure with this number. That is sum of the volumes of D boxes, besides that there is no minimum, there is no below of this number. If I am saying a number of the measure, let's say if I say this mu star L, not L, J D of Y, if I say something like, it is something like, let's say some number alpha, that means that no way, it is not possible you define some other collection on top of this y, some D box collection, in the whose product, whose volume of some of the volumes of D boxes, it's never gonna be below alpha. That is the least one, alpha. So it's not possible to bring it down below alpha. That is called infimum. What is saying? So we are looking for such number. That number is called, that number what we are calling it as the Jordan outer content. Okay, why Jordan outer content? Can you give some why outer? Yeah. Mm. Yeah, it is like we are looking always like from the outside, like we are bringing our D boxes. If you look up that there are small pieces, we find them by keeping that y always keeping inside. We are not looking something like from inside. If it is something like this one inside, we don't want it to bring the refinement from outside, then that's a different one. But we are interested in some kind of like covering of why this subset inside of this one. Like it is a kind of like you have Riemann integration of something, of a curve. Like what do? You have a finite rectangles. It is also a kind of this. You approximate this into the numbers by keeping approximating this outside area, bringing down to the least number by keeping reducing these intervals much finer and finer all the time. That is where you say the uh, Riemann upper limit. And there is something called in the same way Riemann lower limit, that is where the thing on this way, not on the outside. This is, if you define like this, then it is kind of like outer measure. And if you are trying to reduce this number, this volume, this is a inner measure. So there is, I think we have discussed this one in our Riemann integration, where this is the Riemann upper limit and Riemann lower limit. Are we long in the last semester or before? I don't remember exactly.
It's in real analysis, sir.
Yeah, real analysis, Riemann upper limit, Riemann, same thing. Like similar. I don't call it as that and this as the same basket, but similar measurement. When you are coming into the measure, like outer content, we are interested in the the covering of entire Y by the D boxes. Okay, this is you try to understand like the way we write up this one, and the way we understand the way it is working in the diagrammatic way. But ultimately, what we are giving the context is what we started from very beginning. The motivation to give some sense of measure for the subsets. That is where we deal our data in the RD. So the data is not smooth. The data, whatever you do it in the models, that is not just like D boxes. They are not perfectly sharply cut D boxes. They behave differently. So those things we need to measure very describe much better, much understand to understand subsets. Okay, I will define another one more definition and I will stop, and you learn that decipher yourself, so that you will very clear, because that is quite similar to the same definition, but it is a slight difference. That is called um, d-dimensional d-dimensional Lebesgue outer measure. Lebesgue outer measure. It's the same if I write up in the same way. I think if I start with the bounded set here, now if it is, if y is not a bounded, any arbitrary set, I am not restricting conditions. Arbitrary set. Uh, okay, I think I should mention it must be a subset of RD we are talking. Any arbitrary set. Then the Lebesgue outer measure is defined as something like mu star Lebesgue, the D boxes D, the dimension it is describing, the subset Y is the same context again infimum of summation of. Now here earlier we have restricted to K D boxes. Now I am not restricting the K D boxes. I am going with infinitely many D boxes. Volume of each D box with AN such that here ANs are uh, D boxes with the same condition again. Y is subset of no, y is subset of union of n equal to 1 to infinity an. The same, both are same. Only slight difference is that earlier we have restriction on this y is must be a bounded set, but now I am taking irrespective of any set, any arbitrary set, a finite, bounded, infinite, doesn't matter. So the Lebesgue is much powerful or stronger version than the Jordan, where we are looking for infinite covering. It's not just the finite covering. Earlier we have a finite cover of D boxes, union of n equal to 1 to infinity. Now we have infinite cover of D boxes. What infinite collection? What infinite? This is volume. Yeah, volume of D boxes. The measure coming out of all such possible infinite collection, which one gives the minimum labeled outer measure. Okay, think you may have a next class. We'll meet coming Friday. Right, if you have any questions, you can quickly ask me or I can leave. I think these are just few definitions. We will discuss further.
So there is slight change in our timetable, sir. Like you can take our classes on Monday 9 to 10 if you are serious, sir.
Yeah. I got an update. Like Friday, sometimes I would be having other classes. Maybe,
Yes,
yeah,
sir. Yes,
yeah.
yes, sir.
Maybe this week I will take on Friday as a substitute
Okay,
of
sir.
yesterday's. Then
Okay,
from
sir.
next
Okay,
week
sir.
I will take on Monday. Okay.
Okay,
Okay.
okay, sir.
See you guys.
Thank you,
Bye.
sir. Thank you, sir.
Hello, sir, you're muted.
Sir, you are not audible.